According to the National Electrical Code, all 125-volt, 15 and 20 ampere outlets in basements are required to be GFCI protected. This is because basements are typically damp or wet areas, and ground fault circuit interrupters help prevent electrical shocks in these environments. In this situation, the GFCI outlet that was serving the sump pump tripped, indicating a fault in the electrical system. The electrician who replaced the well-pressurizer tank should have replaced the GFCI outlet as part of the repair. The NEC does not require ground fault circuit interrupters to be installed on outlets that are solely used to power sump pumps. This is because sump pumps are designed to operate in wet environments and are typically equipped with their own built-in safety features. While not required by code, it is a good safety practice to install ground fault circuit interrupters on all basement outlets, including the one for the sump pump. This provides additional protection against electrical shocks, especially if the sump pump fails or there is flooding in the basement. Understanding ground fault circuit interrupters is important for electrical safety, especially in areas prone to moisture like basements. A ground fault circuit interrupter, or GFCI, is a fast-acting circuit breaker designed to shut off electric power in the event of a ground fault. What is a ground fault? A ground fault occurs when electricity strays from its intended path and flows to ground. This can happen if a person comes into contact with a live wire, or if there's a short circuit where electricity is leaking to a grounded surface. Ground fault circuit interrupters are designed to detect these faults and quickly cut off the power, preventing serious injury or even death. The National Electrical Code, or NEC, sets the standards for electrical installations in the United States. The NEC mandates the use of ground fault circuit interrupters in specific locations to enhance safety. The code requires ground fault circuit interrupter protection for 125-volt, 15 and 20 ampere receptacles in locations where there's an increased risk of electric shock. These locations typically include bathrooms, kitchens, garages, and outdoor areas, and basements. Ground fault circuit interrupters work by monitoring the current flowing into and out of a circuit. If there is an imbalance of just a few milliamps, the ground fault circuit interrupter trips and cuts off the power. This happens very quickly, typically in a fraction of a second, minimizing the risk of electrical shock. There are two main types of ground fault circuit interrupters. Firstly, receptacle type ground fault circuit interrupters are installed as part of the outlet itself, replacing a standard receptacle. Secondly, circuit breaker type ground fault circuit interrupters are installed in the electrical panel and provide protection for the entire circuit. When a ground fault circuit interrupter trips, it indicates that a ground fault has been detected. It's important to identify and correct the cause of the ground fault before resetting the ground fault circuit interrupter. If the ground fault circuit interrupter trips frequently, it may indicate a more serious problem that requires the attention of a qualified electrician. While ground fault circuit interrupters offer significant protection against electric shock, they don't protect against overloads or short circuit. For these types of faults, standard circuit breakers or fuses are used. Ground fault circuit interrupters should be tested regularly to ensure they are functioning properly. This can be done by pressing the test button on the ground fault circuit interrupter. The ground fault circuit interrupter should trip and cut off the power. If it doesn't, the ground fault circuit interrupter may be faulty and need to be replaced. When installing or replacing ground fault circuit interrupters, it's important to follow the manufacturer's instructions and local electrical codes. If you're not comfortable working with electricity, it's best to hire a qualified electrician to do the job. Ground fault circuit interrupters are an essential safety device in any home or building. By understanding how they work and where they're required, you can help protect yourself and your family from electrical shock. In the case of sump pumps, the NEC provides an exception to the ground fault circuit interrupter requirement. Sump pumps are often used in basements or crawl spaces to remove water and prevent flooding. Because they are designed to operate in wet environments, they are typically equipped with their own built-in safety features. For this reason, the NEC doesn't require ground fault circuit interrupter protection for receptacles that serve only sump pumps. However, even though it's not required by code, it's still a good idea to consider using ground fault circuit interrupter protection for sump pump circuits. This can provide an extra layer of safety in case of a fault or failure in the sump pump. In some cases, a dedicated circuit may be required for a sump pump, depending on its power requirements. This means that the sump pump is the only device connected to that circuit. This can help prevent overloads and ensure that the sump pump has enough power to operate properly. When choosing a location for a sump pump receptacle, it's important to select a spot that is easily accessible and protected from moisture. The receptacle should be mounted above the expected water level to prevent it from being submerged in case of flooding. It's also important to ensure that the receptacle is properly grounded to prevent electrical shock. Proper grounding helps to provide a safe path for electricity to flow in the event of a fault. Regular inspection and maintenance of some pumps and their electrical connections can help prevent problems and ensure reliable operation. This includes checking the receptacle, wiring, and ground fault circuit interrupter to make sure they are in good condition. It's also a good idea to test the sump pump periodically to make sure it's working properly. In addition to ground fault circuit interrupters and dedicated circuits, surge protection can also be beneficial for some pumps. Surges in electrical power can damage the sump pump motor and other components. Surge protectors can help to protect against these surges and extend the life of the sump pump. When working with electricity in wet environments, it's essential to take precautions to prevent electrical shock. This includes wearing rubber gloves and boots and avoiding contact with water while working on electrical equipment. It's also important to turn off the power at the circuit breaker before working on any electrical circuits. If you're not comfortable working with electricity, it's best to hire a qualified electrician to do the job. Electricians have the training and experience to safely install and maintain electrical systems. They can also help you identify and correct any electrical hazards in your home. In conclusion, while ground fault circuit interrupter protection is not required by the NEC for sump pump receptacles, it's still a good idea to consider using it for added safety. Proper installation, maintenance, and precautions can help ensure the safe and reliable operation of sump pumps and other electrical equipment in wet environments. Basements often present unique challenges when it comes to electrical safety due to their potential for dampness and flooding. It's important to take extra precautions to protect yourself and your family from electrical hazards in these areas. Firstly, ensure all basement receptacles are ground fault circuit interrupter protected as required by the NEC. This includes receptacles for lighting, appliances, and other equipment. Ground fault circuit interrupters can help prevent electrical shock in damp or wet conditions. Secondly, consider using waterproof or weather-resistant electrical boxes and fittings in basements. These can help protect electrical connections from moisture and corrosion. They are especially important in areas that are prone to flooding or dampness. Thirdly, keep electrical cords and equipment away from water sources. Avoid running cords across wet floors or near sinks, tubs, or other areas where water may accumulate. If a cord or piece of equipment does get wet, unplug it immediately and allow it to dry completely before using it again. Fourthly, install a sump pump to remove water from the basement and prevent flooding. Make sure the sump pump is properly grounded and connected to a ground fault circuit interrupter protected receptacle. Regular maintenance of the sump pump is also important to ensure it's working properly. Fifthly, consider using a battery backup for your sump pump. This can provide power to the sump pump in the event of a power outage, preventing flooding and water damage. The battery backup should be tested regularly to make sure it's working properly. Sixthly, install a water alarm to alert you to the presence of water in the basement. The alarm can provide an early warning of flooding or leaks, allowing you to take action to prevent damage. The water alarm should be placed in a location where it can easily detect water, such as near the floor or in a sump pit. Seventhly, elevate electrical outlets and equipment above the floor. This can help prevent them from being submerged in case of flooding. Outlets should be mounted at least 12 inches above the floor. Eighthly, use ground fault circuit interrupter protected extension cords when working in the basement. This can provide an extra layer of protection against electrical shock. Extension cords should be in good condition and free from damage. Ninthly, have your basement electrical system inspected by a qualified electrician. The electrician can identify any potential hazards and recommend solutions to improve safety. Regular inspections can help prevent electrical problems and ensure the system is up to code. 10thly, educate your family about electrical safety in the basement. Make sure everyone knows how to identify and avoid electrical hazards. This includes teaching children not to play with electrical outlets or cords. By taking these precautions, you can help create a safer environment in your basement and protect yourself and your family from electrical hazards. Remember that electricity and water can be a dangerous combination, so it's important to be extra careful when working in damp or wet areas. In addition to the specific requirements for basements, there are also general electrical safety tips that apply to all areas of the home. These tips can help prevent electrical shocks, fires, and other hazards. Firstly, never overload electrical outlets or circuits. Overloading can cause the wires to overheat and create a fire hazard. Use a power strip with a built-in circuit breaker to protect against overloads. Secondly, replace damaged or frayed electrical cords. Damaged cords can expose live wires and create a shock hazard. Check cords regularly for signs of wear and tear. Thirdly, use the correct size and type of light bulbs and fixtures. Using the wrong bulb can cause the fixture to overheat and create a fire hazard. Check the fixture for the maximum wattage rating. Fourthly, keep flammable materials away from electrical equipment. This includes paper, cloth, and other materials that can easily catch fire. Maintain a safe distance between flammable materials and electrical equipment. Fifthly, never use water to put out an electrical fire. Water can conduct electricity and create a shock hazard. Use a fire extinguisher that is rated for electrical fires. Sixthly, turn off the power at the circuit breaker before working on any electrical circuits. This can prevent accidental shocks. Always test the circuit to make sure the power is off before starting work. Seventhly, install smoke detectors on every level of your home. Smoke detectors can provide an early warning of a fire, giving you time to escape. Test the smoke detectors regularly to make sure they are working properly. Eighthly, have your electrical system inspected by a qualified electrician every few years. Regular inspections can help identify potential problems and ensure the system is up to code. The electrician can also provide recommendations for improving safety. Ninthly, know the location of your electrical panel and how to turn off the power in an emergency. This can be important in case of a fire or other electrical hazard. Practice turning off the power so you are prepared in an emergency. 10thly, teach your family about electrical safety. Make sure everyone knows how to identify and avoid electrical hazards. This includes teaching children not to play with electrical outlets or cords. By following these general electrical safety tips, you can help protect yourself and your family from electrical hazards in your home. Remember that electricity is a powerful force that should be treated with respect. If you are ever unsure about how to handle an electrical situation, it's best to call a qualified electrician for assistance.